Have you ever wondered how even the most solid rocks can crumble and change over time, sometimes due to forces you might not immediately consider? It is a fascinating process that shapes our planet's surface. Yes, absolutely. Salt crystallization, also known as salt weathering, is indeed a significant form of mechanical weathering. It is a process where physical forces break down rocks into smaller pieces without changing their chemical composition, and salt plays a very important role in that. The core mechanism behind this phenomenon starts with saline water, which is water containing dissolved salts, seeping into the tiny cracks and pores within rocks. As the water evaporates, it leaves the salt crystals behind. These crystals then grow in size, exerting immense pressure on the rock walls, much like a tiny wedge being driven into a crevice. This internal pressure eventually causes the rock to fracture, flake, or crumble, leading to its physical disintegration. This process is particularly effective because it relies purely on the physical expansion of the salt, making it a classic example of mechanical, not chemical, weathering. You can often observe the effects of salt crystallization in arid and semi-arid regions, as well as along coastlines, where evaporation rates are high. Look for characteristic features like honeycomb weathering, which are small, cavity-like formations, or granular disintegration, where the rock surface appears to be flaking off in tiny grains. These are telltale signs that salt is actively contributing to the breakdown of the rock. Geologists refer to this specific type of weathering as haloclysty, a term derived from Greek words meaning salt and to break. It is important to note that different types of salts, such as sodium chloride, sodium sulfate, or magnesium sulfate, can cause varying degrees of stress and breakdown depending on their solubility and crystallization habits, adding another layer of complexity to this powerful natural force. Understanding salt crystallization helps us appreciate the intricate ways that natural forces, even seemingly subtle ones, contribute to shaping our planet's diverse landscapes. It highlights how the presence of dissolved minerals, combined with environmental conditions like temperature and moisture, can drive significant changes in rock formations over long periods.